Hey everyone, let's solve one previous question of TOC. This question was asked in GATE CS 2025 set 2 question number 42. Let sigma equals to ABC for x equals to sigma star and alpha belongs to sigma. Let hers alpha x denote the number of occurrence of alpha in x. Which one or more of the following options define regular language? And 4 options are given. Let's check one by one option. Option A power m, b power n, m(n) greater than equals to 0. There is no relation between m(n). Individual m and n can be greater than equals to 0. So it's same as A clean closure, B clean closure. Any number of A followed by any number of B, and we know this is a regular language. Hence option A is regular. Next option B, A, B whole clean closure intersection A power m, B power n, C power m minus n, m greater than equals to n greater than equals to 0. Here the first part A, B whole clean closure, that is any strings of A, B, that is a regular language. We know it is A plus B whole clean closure. Now A power m, B power n, C power m minus n. Here number of C's should be number of A minus number of B. Like suppose AA, 2A, B, C. So there is 1C, 2A, 1B. So 2 minus 1, 1. Suppose 4A, 2B, then there will be 2C. 4 minus 2, 2. And DFA have no options to compare number of A and number of B and store their difference. Hence this language is not regular. First part is regular but second part is not regular. But in question it is asking their intersection. So what will be their intersection? It will be A power m, B power n, and m should be greater than equals to n should be greater than equals to 0. Means number of A followed by number of B and number of A should be greater than equals to number of B. And DFA doesn't have storage to compare number of A and number of B. It cannot compare whether number of A is greater than or equals to number of B. Hence this intersection is also not regular. So we found option B is not regular. Next option C, W belongs to A, B whole clean closure. Number of A equals to 2 mod 7 and number of B equals to 3 mod 9. I already discussed DFA for finding mod. It's easy. 2 mod 7 and 3 mod 9. It is possible in DFA. Hence option C is regular. A DFA can count number of A mod 7 and number of B mod 9. Suppose number of A mod 7, we can design a DFA like this. So state can be 0, 1, 2, 3, 4, 5, 6. When we are dividing number of A with 7, remainder will be 2. So 0, 1, 2, 3, 4, 5, 6. These are the remainder for mod 7. And from here we can add a transaction to first state. Now for 2 we can make this as a final state, right? So it will accept 2, 9, then 16 number of A like this. For number of B equals to 3 mod 9, we can also create similar type of DFA and we can merge these two and we will get the answer. So option C is also regular. Next option D, W belongs to A, B clean closure. Number of A in W equals to 2 mod 7. We can do this by DFA. Then number of A in W equals to number of B in W. This is not possible. We cannot compare number of A and number of B in the string. Hence option D is not regular. We found option A is regular, option C is regular, whereas option B and option D are not regular. Answer will be option A and option C. Whenever there is comparison, DFA cannot compare, right? So any language including comparison cannot be regular. As DFA have no memory, it cannot store the information. I already discussed this type of language during lecture. Just go through the lecture, and if this lecture is helpful for you, please like, share and subscribe. Thank you. Bye-bye.